Let's have a look at projectiles and when we launch them horizontally. To do this, we're going to work through an example. So a coin rolls off a table with a speed of 0.3 meters per second. We're asked how far will the coin move from the base of the table if the height of the table is 1.25 meters. So the first thing that we always do is draw a diagram. So we have our table, we have our height at 1.25 meters, we're launching our coin with an initial velocity of 0.3 meters, and that is in the horizontal direction only. Now over time, this object will travel through space in a parabolic curve, as we saw in our last video, until it reaches a point from the base that's our unknown that we're asked to find in the question. Now, things that we know at this point in time, we know our horizontal initial speed, ux, which is also equal to vx, which is equal to 0.3 meters per second. We also know our height vertically, in the y direction of 1.25 meters. We also know our acceleration due to gravity in the y direction. Because our object is moving down, we're going to say that this is in the plus direction down here. And we're asked for the displacement or the distance in the x direction. Now to do this, we need to go through two parts. And we should always remember that the time that the object is in flight is always determined in the vertical direction. So the first thing we need to do in order to calculate our total displacement in the x direction is calculate the time aloft. To do that, we use our equation s equals ut plus a half at squared. We're just doing it in the y direction. So we know that our initial speed vertically is 0, therefore this component isn't present to begin with. So t squared is going to equal 2s over a, or t is going to equal the square root of 2s over a. We put our numbers in, 2 times 1.25 over 9.8 gives us a time in flight of just over half a second. Now we can use this value then to calculate the displacement horizontally. We use our equation horizontally, s is equal to ut, all in the x direction. Remember that this would be s equals ut plus a half at squared, which our a is 0, therefore our half at squared is also 0. So once we plug in these numbers, we've got 0.3 for our initial velocity in the horizontal direction. We've got a time now that we calculated here, 0.51 seconds, which gives us a total displacement in the x direction of 0.16 meters. Now the most important part is that time aloft is always determined by the vertical component. Once we get that, we can use that then to calculate our range.